Okay, so let's try the next coding exercise. So open the leetcode.com and go to the problems tab. And in the search question number 121, hit enter. So there is a question, number 121, best time to buy and sell stock. So it's the easy category. So click on it. So let's read the question. You are given an array prices. So we have some arrays given prices, where price of I is the price of a given stock on the ith day. So as an example, what they said is, so we have some array is given 7, 1, 5, 3, 6, 4. So these are just the prices. Prices means on day one stock price is 7. On day two stock price is 1. On day three stock price is 5. On day four stock price is 3. On day 5 it's 6, and on day 6 it's 4. Okay, so these are just the stock prices on the ith day. So you can say on the 0th day or 1 day. So basically 0, 0, 1, 2, 3, 4, and 5. So these are the stock prices. Now you want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell the stock. So what you have to do is you have to buy the stock. You have to buy the stock at 1 day, and you have to sell the stock at another day. And now you know the selling price, right? But you need to maximize the profit. So as an example, so if you buy on the first day, and first day means if you buy on the 7, and if you sell on second day, which is 1, so you purchase the particular stock at rupees 7 and you are selling at rupees 1, so you will bear a loss. 7 minus 1 is equal to minus, sorry, selling is 1, buying is 7, so you will have a loss of minus 6, right? So you need to find, like, at what time should I purchase, and should I at what day should I purchase and at what day should I sell, so that the profit is maximum, right? So one approach is, also you return the maximum profit can achieve the, if you cannot achieve any profit, return 0. So as an example, let's suppose if by every scenario you could not find any profit, so profit should be, so we need to find a profit, so profit should be always greater than or equal to 0. So if it is negative, then it is a loss. So this is a loss. So we need to find the profit, right? So let's suppose if we will not find any day, then we have to return a profit as a 0. So as an example, let's suppose the array is 7 and 1. Only these two array. So only the condition is I can purchase on 7 and I can sell on 1. Then there is a loss, so there is no profit. So the output will be 0 in this case. Along with that, the price's length can be equal to 1. So if the price's length is equal to 1, let's suppose this only, right, greater than or equal to 1, then it means I can only buy, but I can't sell. So the profit should be 0, right? So how we are going to solve the question? So we know we need to find the maximum profit. So first approach is, let's try each and every combination. So as an example, so if you see this thing, this side of scenario where I'm putting the line. So this side of scenario. So what I will do is, if I purchase at 7, right? And if I purchase at 7, then what will be the profit? If I sell at 1, if I sell at 5, if I sell at 3, if I sell at 6, if I sell at 4. So by keeping at 7, I will check with every other day. If I purchase at 7 and if I sell at 1, then we have the loss minus 6. If I sell at 5, then the loss of minus 2. If I sell at 3, then the loss of minus 4. If I sell at 6, then the loss of minus 1. If I sell at 4, then the loss of minus 3. So no profits. All right. So okay, so it means it's like a bad thing if we purchase at 7. Right. So if I purchase at 1, if I purchase at 1, so I can't sell on the 7 because I purchased on the second day. So if I purchase the stock on the second day, how I can sell the stock on the previous day? No. If I purchase on the second day, I have to sell on the next day only. So if I purchase at 1 at the price of 1, and if I sell at 5, then the profit is 4. If I sell at 3, then the profit is 2. If I sell at 6, then 6 minus 1 is equal to 5. If I sell at 4, then 4 minus 1 is equal to 3. So till now, maximum profit is 5. Okay, then we will try next one. So if we purchase at 5, then and sell at 3, then the profit is minus 2. If I sell at 6, then the profit is 1. If I sell at 4, then the profit is minus 1. So here the profit is 1, but the maximum is 5. So in the same way, like we will like check each and every scenario. We will first try this approach which is coming first in the mind, and we will try to see is the lead code is going to accept our problem or not. Right. So first condition is this condition we can handle, that is the boundary condition if the price's length is greater than or equal to 1. So we can calculate the length of the prices. Okay. So if n means length of prices is less than or equal to 1, then we need to return 0. Then we need to return 0. Okay, that is the maximum profit. So there is no profit. We can return a 0 profit. Okay, so what else? What we have to do, we have to check each and every combination. So we have to start from 1, but till what point we have to go? Do we need to go till 4, or do we need to go to still 6? If we go till 4, so if we purchase at 4, then when I will sell? So I can't sell, right? Because there is no next day. So it means I need to run first loop till 6 only. So let's try for I in range of n minus 1, because I need to run a loop till 6. Okay. The second loop should be start from 1, right? So if the first loop is starting from 7, then the second loop should be start from the I plus 1. If I is 0, then it should be I plus 1, but it can go till end because that is the selling price. So for j in range of I plus 1 till n. Okay. Now what next? Now in the first loop, selling price is 7. Oh, sorry, 1 minute. Uh, sorry. So in the first loop, I is 7, and we can compare with everyone. So I is 7, and then we can compare with all the elements. Okay. So what we can check, we can calculate the profit. Okay, what could be the profit? Prices at J means we have to selling price minus prices at I. So J means like either 1, 5, 7, 3, 6, 4, and price is at 7. So buying price. Right. So this is what we can do if profit is greater than max profit. So we can take some max profit variable. So let's try max profit is equal to 0. If profit is greater than the max profit, then we have to update the max profit. Then max profit is profit. Till now the max, so because like in first scenario, so there are no, in first scenario everything is negative, so we, it means till now profit is 0. In the second scenario, as soon as it will come, 4 will come, so max profit is 4. So this time max profit is again 4. So this time because we are checking the max profit, so this time 5, max profit is 5. This time max profit is still 5. So after checking each and every condition, we have to return the max profit. So let's try to run our sample test cases. So our sample test case has been accepted, but let's try to submit. Whether Leetcode is going to accept this of and scare solution or not. Hopefully it is not going to accept. Yeah, correct. So 198 test cases has been like accepted, but still 13 test cases has been failed. And because of time limit exceed. Because if it is like huge array, then we are like checking for each and every element. All right, so that is taking a huge time. So that's why like the few test cases has been failed. So it means this solution is not going to work. But this is the first solution which will come in like anyone minds. Okay, okay. So leave that solution. Leave this solution, which is perfectly fine. Okay, now this solution is like is not working. Okay, what is the second solution which we can come in mind? So let's suppose if you are purchasing at 7, right? So let's suppose the like we need to find the maximum profit. So how you are going to achieve the maximum profit? Maximum profit means you need to purchase the stock at the minimum price. At the minimum price, whenever the price is minimum, you need to purchase at that time, and you need to sell the stock at the maximum price, right? At the maximum price, right? So we will run one loop, right? So or you can say like we need track of two pointers. One is the minimum pointer, and then the other pointer is going to do. So you can say a kind of a sliding window problem. So let's suppose we will start from 7. We say okay, we will because right now, because when we run a loop, in front of us it is only 7, right? So we will consider okay, maximum minimum price is 7, right? So if I purchase at 7, right, the minimum price is 7, then I will check the other element, right? So in the initial stage I am going to set the minimum price even without running a loop. So minimum price is 7, which I know, like I am assuming minimum price is 7. Then I am going to run a loop from 1 to 4. 1 to 4. Okay. Now I have found the next element is 1. So I will check if the 1 is less than 7. So if the 1 is less than 7, then I should not going to calculate the profit, because this is the smaller element. Doesn't matter how much. Then I what I will update is I will update the minimum price to 1, because because how the stock could be in the maximum profit when you are going to purchase the stock at the minimum price. So use we assume okay, the minimum price is 7, but we found the 1. So the minimum price now is 1, because as an example, let's suppose um, we have 7, we have 1, right? Now you might think why we are considering 7 1 instead of 7, because we have to calculate the difference. It could be more, any number of element after cup. It could be 100, it could be 200, it could be 400 after that, right? But 100 minus 7 is always smaller than the 100 minus 1. All right. So as soon as I found the next smaller element, I will update. This is my minimum element. This is my minimum element. All right. So now, okay. So let's try to do the question. So first I need to handle the boundary condition. First I need to handle the boundary condition. So n is equal to length of prices, and if n is less than equal to 1, then I'm going to return 0. Along with that, I need to take the max profit, which I need to calculate, and by default, we can take 0. Along with that, we need to assume the minimum price, and the minimum price is like the first element, price is of 0, right? And then, so I told you, because the first element we will consider as a minimum, and then we will run a loop from 1 to 4. Okay. Then we need to run a loop for I in prices of 1 1 to end. For price in, you can say for price in prices of 1 to last, right? So now, so what's the next element? So I found the 1 minute. So 1 minute, let me rub this. So minimum price, I assume it's 7. Fine. Now I need to run the loop from here to next its end. So I found the one, right? So as I found the one, I'm not going to subtract because I know I need to find. First, I will like I found the I one. I will compare with my minimum price. So if price is less than minimum price, if price is less than minimum price, then I am just going to assign one to the minimum price. Then my minimum price should be price. Then minimum price should be one. Now, so by this approach, now my loop is going to start from one to five. By this approach, I I am just like skipping this whole loop because unnecessary what I did is earlier we are subtracting 1 minus 7 minus 6, then again I am subtracting 5 minus 7, then again I am subtracting 3 minus 7. But why I need to subtract? Because I need to find the maximum profit. How you can achieve the maximum profit? You can achieve the maximum profit when you are going to purchase the stock at the minimum price. So I assume, okay, the minimum price is this. As soon as find another element, the minimum price should be this. If the minimum price is this, then why should I check like all the element with the 7? There is no need to check all the element with the 7. Then if I have to check all the element, I will check with the 1 because that is the minimum price, right? So if the minimum price is 1, then I am going to consider, okay, minimum price is 1. Then again start the loop. Then again start the loop, right? So minimum price is 1. Okay, else. So now it's 1. All right. So now my pointer will go to the 5. Now my pointer will go to the 5. So then I am again going to compare whether 5 is less than 1. No, 5 is not less than 1. Then I am going to calculate the profit. So let's calculate the profit. So profit is equal to uh, prices of I minus minimum price. Right now I'm going to calculate the profit. Let's calculate the profit because the next is the biggest element. So let's calculate the profit. I will check if profit is greater than the max profit. Is it greater than the max profit? Because 5 minus 1 is equal to 4. Yes, it is greater than the max profit. Then I'm going to assign the max profit value to the profit. All right. Okay, which is fine. So now it's 4. Now my loop will run again. So now it's go to 3. It's go to 3. Then uh, then I am going to check because 3 is not less than 1. Then I'm going to check 3 minus 1 is equal to 2. Whether 2 is greater than the maximum profit? No. So that's it. So now I'm going to go again 6. So whether 6 is like 6 minus 1, 5, whether 5 is greater than the maximum profit, which was 4. Yes. So I'm going to update the maximum profit. Then with the 4, so 4 minus 1, 3. So I'm not going to update because 3 is less than the 5. All right. So you may question like because okay. So 1 minute. Let's suppose if the array is 7, 2, 5, 3, 1, 6, 4. Now you may question if the array is this, then okay, minimum price is 7, which is perfectly fine. Then we are checking 2. Then out of 7 and 2, 2 is minimum. Then we are we don't need to check 7 with all the elements. Then we will start from the 2. Okay, 5 minus 2, 3. So max price is 3 till now. 3 minus 2 is 1, which is less than 3. Now we found the 1. Now we found the 1. So now we found the one which is smaller than my minimum price, which is smaller than my minimum price. All right, which is small. Then I am not going to check 2 with 6. I'm not going to check with 4 because even if I'm going to check 2 with 6, 6 minus 2 is equal to 4. But 1 minus 6 is 5 because doesn't matter how many bigger element will come after 2. If if after 2 there is a one smaller element, then doesn't matter how many bigger element will be there. Subtraction will be more with this element. All right. So if I as soon as find my less element, I'm going to assign the minimum element to this element. So I will consider, okay, minimum element is this. Now I'm going to calculate 6 minus 1, 5. Okay, is it greater than the previous element? Yes, now I'm going to update. So is it 4? 4 minus 1, 3. It is greater? No. So the same thing which we are doing, and at the end, we will return max profit. So let's try to run it. Something is prices of, okay, so it's price only, price minus minimum price. So let's try to run it. So sample case has been accepted. So let's try to submit. So you could see as soon as we just run the one loop, we beat 96% of the people. We beat 96% of the people. Right? Because we are skipping so many loops. Because in this scenario, we skip seven with we just check seven with two. We are skipping everything. Now, if we just check two till one. We are skipping two with six and four because we found the minimum element. Then we don't need to check with six and four because as soon as we found the minimum element, doesn't matter how many big element will be there. It is always good. Instead of at rupees 2, you should purchase at rupees 1, right? So we will find, we will check this element. But anyhow, for the 2, we have the maximum profit till now because it could be the thing. After 2, it could be again 1 and again 1. After 1, it could be again 1 and again 1. So maximum price could be 3, right? So that's why, like, we are in this way, we are skipping and we are just running one loop, and which will like sort our like decrease our time complexity. So this is the easy category question. If you going with the like this approach, then it's very easy because you have to just check each and every combination. But we using this approach, 190 test case pass, that is still okay. But few test cases are left. But we need to make sure like all the test cases passed. So the best approach is this one. We can use the sliding window. So why it is called a sliding window? Because we are putting one pointer here, that is the minimum price pointer, and we are going further. As soon as we find the minimum, then we are putting one pointer here, then we are going further. So the window is sliding, so that's why it's called a sliding window. So that's it. That's the end of the video. Thank you.